Around 252 million years ago, Earth's biosphere suffered a cataclysmic blow that nearly reset the planet to a lifeless rock. The Permian-Triassic extinction, often called the Great Dying, wiped out 96% of marine life and over 70% of terrestrial vertebrates. Even the resilient insects weren't spared. In geological terms, this collapse happened in a heartbeat, leaving behind nothing but a silent wasteland. While scientists still debate the exact trigger of this chaos, one thing is certain: life refused to break. Instead, this tragedy laid the foundation for the most iconic chapter in Earth's history. From the ruins of the Old World emerged the legends we all know today, the dinosaurs. The end of the Permian gave birth to the Mesozoic era, a 186 million-year reign of transformation. This was the age when Earth began taking its modern shape, driven by the slow-motion breakup of the supercontinent Pangaea. The massive landmass first split into Laurasia and Gondwana, eventually fracturing into the continents we recognize today. These shifting boundaries created isolated evolutionary laboratories, unique ecosystems separated by new seaways. The Mesozoic was the greenhouse phase of complex life. It was so warm that permanent ice sheets didn't exist, even at the poles, and polar nights lacked the brutal freezes we see now. Yet, the climate wasn't static. Periodic cooling forced plants and animals to innovate or perish. Act 1. The Triassic Period. The story begins with the Triassic, a 51 million-year recovery phase. At this time, Pangaea was still largely intact. The Ural Mountains, which we now see as ancient rolling hills, were then jagged, towering peaks in their prime. The Triassic air was harsh, dry, scorching, and thin. For a long time, oxygen levels hovered at a suffocating 10%, only spiking to 19% toward the end of the period. This oxygen surge likely fueled the expansion of new flora. Ancient seed ferns retreated, making way for more advanced groups: cycads, ginkgos, and the ancestors of modern conifers. As the first true forest took root on land, the oceans, once emptied by extinction, found new masters. Turtles, bony fish, and primitive ichthyosaurs began their long journey to dominate the deep. This grueling recovery was the prologue to a grand biological triumph. From the ash and chaos emerged a complex, harmonious system that would define our planet for millions of years. The Mesozoic stands as a monument to life's resilience, a testament to how a global catastrophe can become the ultimate springboard for an unprecedented evolutionary leap. The tone shifts. The visuals grow harsher. We're in the Cretaceous period, northern Alaska. No lush jungle here, just snow, bitter cold, and months of polar darkness. This is the world of Nanooksaurus, a smaller, thickly feathered cousin of T-Rex, built for survival where giants couldn't afford to exist. What it lacked in size, it made up for in intelligence and parental instinct, raising and training its young through seasons of near-zero food supply. Meanwhile, far to the south, a quiet revolution was underway. The first flowers were blooming. This green coup rewired the chemistry of the soil itself and cracked the door open for a new class of hero: small mammals. Enter Repenomammus, stocky, fearless. At dusk, this thing didn't hide from dinosaurs, it hunted them. Fossils have confirmed it could take down juvenile Psittacosaurus, flipping the predator-prey script entirely. Life at the polar edge demanded a completely different biological playbook. Unlike their massive cousins thriving in warmer latitudes, polar tyrannosaurs had to stretch every calorie across long Arctic twilight. Dense, fur-like feathers locked in metabolic heat, even when temperatures dropped below freezing. These weren't just killing machines. They were sophisticated hunters with sharp vision, fine-tuned senses of smell, and a level of parental investment that points to surprisingly complex neural wiring. While the North tested its reptiles to the limit, the rest of the world was quietly being rebuilt from the ground up. Flowering plants didn't just change the landscape, they engineered an entirely new food web. Nutritious seeds and fruits became available to more species than ever before, triggering an explosion in insect diversity and fueling the rise of small vertebrates. Their deep root systems transformed soil fertility, which in turn altered runoff chemistry, rippling all the way down to coastal marine ecosystems. Mammals were no longer shadows in the undergrowth. They were specialists now, carving out niches that had never existed before. Repenomammus wasn't an outlier, it was a preview. Beneath the canopy of giant forests, a hidden arms race was accelerating. Every adaptation mammals forged in that shadowed struggle, metabolic efficiency, behavioral flexibility, sharp cognition, would become the foundation of their future dominance. Meanwhile, the planet itself kept shifting. India drifted northward across open ocean. South America severed its last connection to Africa. A slow global cooling crept in at the end of the period, forcing migrations and new cold weather adaptations, even among the most powerful dinosaurs. The oceans weren't spared either. Underwater volcanism and shifting currents slashed oxygen levels, triggering mass die-offs among the great marine reptiles. The Cretaceous world was a system in tension. Ancient giants and lean, adaptable newcomers locked in an uneasy balance. But the whisper of evolution growing louder in the polar forests? That was the sound of the future being written. The screen bleeds crimson. We go back to the beginning. 252 million years ago. The Great Dying had turned Earth into a scorched wasteland. 96% of marine life, gone. The camera sweeps across cracked, barren ground and the handful of species that somehow made it through. This is ground zero. But this is also where the Triassic is born. The young Ural Mountains tear into the sky, twice as tall as they stand today. And then something invisible happens that changes everything. Atmospheric oxygen spikes from a suffocating 10% to 19%. That silent surge acts like a shot of adrenaline straight into the veins of a recovering planet, and the archosaurs are first in line to cash in. The landscape was brutal. Sun-scorched plains stretched across Pangaea, broken only by deep canyons where the last embers of life still flickered. The air was thin, dense with chemical imbalance, but the planet's recovery engine had just switched on. The trigger? A surge of new marine plankton and fast-spreading seed ferns quietly rebuilding the atmosphere from the bottom up. Higher oxygen didn't just help animals breathe, it rewired their metabolism entirely. Suddenly, more energy was on the table. And archosaurs, with their advanced skeletal structure and uniquely efficient respiratory system, were perfectly built to take advantage. They began to diversify at a pace the world hadn't seen since before the extinction. Limbs shifted underneath their bodies, a seemingly small anatomical tweak that delivered massive gains in speed and endurance over the sprawling reptiles of the old world. They moved into wastelands where nothing large had walked before. On land, the first conifer forests and cycad thickets slowly stitched a green layer back over the earth. In the oceans, water that had spent ages near lifeless and overheated began to cool. Early ichthyosaurs, still awkward, still half remembering their terrestrial ancestors, started making tentative hunting runs in the shallows. The foundations of future ocean empires laid one nervous dive at a time. The Urals loomed over all of it. Those jagged peaks blocked moisture-heavy air currents and carved out unique climate pockets at their base, microclimates where life could experiment in relative isolation. Inside Pangaea, tectonic pressure was quietly building. The supercontinent hadn't broken yet, and that meant animals could migrate freely across vast distances. But the competition for resources was savage. The food web hadn't recovered to pre-extinction abundance, and every new evolutionary trait was the difference between a lineage surviving or vanishing. The first dinosauromorphs emerged in the middle of all this chaos, faster, sharper, more drought-resistant than anything that came before. The ash of the Great Catastrophe was slowly being absorbed into the soil, becoming fertilizer for something the planet had never grown before. These creatures were taking their first uncertain steps across a scorched, slowly healing world. But make no mistake, evolution wasn't just patching the damage, it was rebuilding from scratch, more complex, more adaptive, more ambitious. Every sunrise over the jagged Ural peaks brought sounds the Earth had never heard. Species that would one day become legends were still learning to walk. The greatest biological race in Earth's history had just fired its starting gun. The Triassic world is full of strange, in-between things. Scurrying through the sand and conifer forests, Oligokyphus, tiny, fur-covered, built like a weasel. It lives underground, nurses its young on milk, and operates with a level of social intelligence most reptiles of its era couldn't dream of. And yet, dinosaurs are still just one group among many. Nobody's crowned king yet. Out in the ocean, things aren't much cleaner. Symbospondylus, 10 meters of awkward ambition, is learning to hunt. It still swims by writhing its entire body like a snake. Its limbs haven't fully become fins yet. Every move through the water costs it more energy than it should. It's not a perfect predator, it's a pioneer. This chapter is about the era before the coronation, when the future rulers of Earth were still just extras in someone else's story. Life in the shadow of the young Urals demanded relentless ingenuity. The climate was dry and punishing. Water sources dried up without warning under a merciless sun. Oligokyphus solved this the smart way. A network of underground tunnels, cool and hidden, where it raised its young away from the heat and the predators above. These were cynodonts, creatures caught between ancient reptile and future mammal, carrying evolutionary blueprints millions of years ahead of their time. Up on the surface, the first true dinosaurs were learning their edge. Small, quick Storikosaurus had figured out bipedal movement, freeing up their forelimbs while everything else was still lumbering on four legs. They weren't giants yet, but in a world where every meal was a competition, speed and freed hands were everything. The landscape itself was hostile. Tough ferns and cycads formed thorny thickets along the banks of scarce rivers. Crocodile ancestors and amphibians still held real power in freshwater ecosystems. Nothing was settled. Nothing was inevitable. Back in the ocean, Symbospondylus kept hunting, inefficiently, expensively, stubbornly. Its long snout full of small teeth was decent for catching fish. Its half-formed fins were better at stabilizing than propelling, but it showed up every day anyway. That stubbornness was the whole point. Every awkward dive laid another brick in the foundation of future ocean empires. Then, slowly, the atmosphere kept shifting. Oxygen crept higher, and higher oxygen quietly rewired the evolutionary odds in favor of creatures with faster, hotter metabolisms. Toward the end of the Triassic, the rains started coming back. Deserts retreated. Conifer forests pushed forward. The accumulated weight of 1,000 small changes finally hit a tipping point. Dinosaurs began to grow. Fast. The slower competitors got squeezed out, one by one. While Oligokyphus kept its head down in the undergrowth, enormous shadows started falling across the land. The age of equals was ending. The Titans were clocking in. The stage was almost set. Pangea on the verge of splitting, the last patient contenders about to claim what they'd been waiting for. Every creature in this world, from the smallest burrower to the largest sea hunter, had played its part in nature's great experiment to rebuild a biosphere from ash. The next dawn was coming, and the world it rose over would never look the same again. The pace quickens. We're back at the end of the Cretaceous. The climate is unraveling. Volcanoes pump ash into the sky for thousands of years straight. Species that once dominated are visibly buckling under the pressure. In the oceans, oxygen levels are crashing. Mosasaurs, the undisputed kings of the sea, are being slowly cornered. On land, even feathered, cold-adapted dinosaurs are losing ground to a climate that no longer plays by any rules they know. Everything living can feel it. Something is coming that doesn't fit any natural cycle that's ever existed. Then, from the void, a rock. Ancient, massive, on a collision course with Earth. It hits the Yucatan. The explosion is millions of times more powerful than every nuclear weapon humanity has ever built, combined. The crust convulses. Tsunamis hundreds of meters tall erase coastlines. Billions of tons of vaporized rock, sulfur, and soot are blasted into the atmosphere, and the sun disappears. Impact winter begins. The sky, once clear blue, is now a permanent gray ceiling of toxic haze. What little sunlight filters through isn't enough to sustain photosynthesis. Tropical forests collapse first. Then the great herbivores, their herds thinning, their bones piling up across valleys that were lush just seasons before. Then the predators, their food chain gone, follow. In the oceans, the water stops circulating. Dead zones expand. Ichthyosaurs and plesiosaurs get pushed toward the oxygen-starved surface. Mosasaurs, rulers of the deep just years before, wash up on the shores of newly formed continents, dead from starvation and suffocation. Acid rain strips the last vegetation from the ground. The temperature swings are violent, relentless. Even species with thick, fur-like feathers can't outlast winters that no longer end. 186 million years of scale and feather, gone. Not slowly, in a geological heartbeat. The dinosaurs that had survived 3 full geological periods, that had adapted to every climate shift, every continental rearrangement, every ecological pressure, they couldn't adapt to no light and no food. That was the one scenario evolution hadn't prepared them for. One by one, the giants went dark. What survived was small, flexible, able to eat almost anything, able to hide underground or underwater and wait. Birds, direct descendants of the theropods, and tiny mammals pressed themselves into whatever cracks remained and held their breath. The ecological vacuum left behind was the largest in the entire Phanerozoic. The stage of the Mesozoic, built over hundreds of millions of years, was stripped bare in an instant. Dust and frozen wind where forests once stood. But underneath the ash, something was still breathing. The curtain had fallen on the greatest show Earth had ever staged, and somewhere in the dark and cold, the next cast was already waiting for their cue. The dust settles. The landscape is empty, but something moves between the rocks. Surviving birds and small mammals crawl out from their hiding places, blinking into a dim, ash-filtered sky. They don't look like heirs to anything, but that's exactly what they are. What follows is a time-lapse measured in millions of years. Forests replace wastelands, grasslands replace forests, ice sheets advance and retreat. The planet reinvents itself again and again, and every time it does, life finds the opening. Mammals, the creatures that spent 150 million years being irrelevant, finally get their moment. With the giants gone and the ecological niches wide open, they explode in size and diversity. Primitive hoofed animals, early predators, the ancestors of everything walking the earth today. The continents keep drifting. India collides with Asia and raises the Himalayas from the seafloor. Ice ages come and go, sculpting valleys and pushing life into new shapes with every cycle. And then, in the forests of a warming world, primates. And from primates, something that doesn't just adapt to the world, something that starts rewriting it. Homo sapiens. The first creature in Earth's 4.5 billion year history to dig up the bones of the previous rulers, reconstruct their faces, and put them in museums. We looked at T-Rex femurs and mosasaur jaws and pterosaur wingspans, and we understood, for the first time, that dominance has an expiration date. Cities now stand where triceratops once grazed. The sky that pterosaurs ruled is full of steel. We split the atom, we peer into the same deep cosmos that sent the rock that ended the Mesozoic. And yet the same vulnerability is still there. It never left. Time measured in millions of years turns all of human history into a single frame. Our greatest achievements are just potential fossils. The question isn't whether the Earth will outlast us. It will. The question is what kind of chapter we choose to write while we're here. Every skeleton in every museum is a quiet warning. Nature doesn't have favorites. The most dominant creatures to ever walk this planet are gone. Not because they were weak, but because the universe didn't care how powerful they were. We stand at the top of the food chain today, but in geological time, we've been here for about 30 seconds. The dinosaurs had 165 million years. We're still in the opening scene. The Earth has survived everything. Mass extinctions, asteroid impacts, volcanic winters that lasted decades. It has always come back, different, renewed, more complex than before. The only real question the Mesozoic leaves us with is this. When the next chapter begins, will we be the fossils or the survivors? Life doesn't stop. It never has. Every ending here has been a rehearsal for something greater.